Good morning and good afternoon to everybody. Thank you for joining us. Today, World Women in Neuroscience, in collaboration with Neuromatch Academy, presents Neuromatch Academy, Computational Neuroscience Across Borders. This webinar is going to be given by Dr. Megan Peters. Dr. Megan Peters is an assistant professor of the University of California in Irvine. She is from the Department of Cognitive Sciences. She's also cooperating a researcher in the Department of Decoded Neurofeedback at the Advanced Neurotelecommunications Research Institute International in Kyoto, Japan. Prior to joining UCI, she was the faculty at UC Riverside in the Department of Bioengineering. She received her PhD in computational cognitive neuroscience from UCLA and then was a postdoc there as well. Her research aims to reveal how the brain represents and uses uncertainty and performs adaptive computations based on noisy, incomplete information. She specifically focuses on how these abilities support metacognitive evaluation of the quality of mostly perceptual decisions and how these processes might relate to phenomenology and conscious awareness. She uses neuroimaging, computational modeling, machine learning, and neural stimulation techniques to study these topics. Please welcome Dr. Megan Peters. I would like to ask you to please remain unmuted until you have questions. If you have a question, please go ahead and raise your hand or put it in the chat. Thank you so much for joining us, Dr. Peters.
Thank you very much to Martha and to all of you for having me. I'm really excited to be here and tell you about not my research today, but about Neuromatch Academy. So let's just go ahead and get started. So hopefully everyone can see this. I'm really happy to talk to you guys today about this initiative that I've been involved in. So this is something that was started about a year ago, and I'll tell you all about how we kind of came to be. I also want to preface this talk by saying that I certainly am nowhere near one of the kind of only or even main parts of Neuromatch and Neuromatch Academy. This is a huge effort from hundreds and hundreds of neuroscientists around the world. And this is just a partial list that I was able to pull off of like our Slack membership here. And I don't even know whether there are even repeated names or anything here, but this is just a representation of the size of this effort and the sheer commitment and love that's just being poured into Neuromatch and especially Neuromatch Academy here, which I'll tell you about today. It's just a heroic effort, and I'm just grateful and proud to be a part of it. So as Martha said, please go ahead and put your questions in the chat if you want, or raise your hand and we'll get to questions at the end. And here we go. So I hope you'll enjoy. So let's just get going. So many of you guys here in this room are probably interested in computational neuroscience. That's why you're coming to this talk. That's why you're interested in hearing more about Neuromatch Academy. And you can get a lot of really fantastic computational neuroscience education and education in topics related to computational neuroscience from your university, of course. So many of you are potentially in computational neuroscience or related programs, either at the undergraduate or graduate level, or maybe you're a postdoctoral researcher, or you're just kind of interested in learning more. But your university education is really a great way to do this, of course. So you can get targeted courses in neuroscience and computer science and mathematics and so on. But even if your university has these departments or courses, and especially if it doesn't, because computational neuroscience doesn't exist at every institution, there's still a lot of space and value for intensive computational neuroscience education in a more compact schedule. And what I mean by that is these summer schools and workshops that happen throughout the world. And usually they happen in the summer, and sometimes there's winter ones as well. And there are a lot of these intensive summer schools for computational neuroscience alone. And so this is proof that there's really value in these intensive summer schools. So here's an example of just some of the summer schools around the world that are focused on computational neuroscience. And if you haven't had a chance to check out some of these, I encourage you to do so. They're kind of everywhere. Some of them are in Europe, some of them are in the Americas, some of them are in Asia. This one's in Japan. But it's not just education that you get from these computational neuroscience or other intensive summer schools in whatever your target area is. So yeah, you get education, but you also get lifelong science friends and a lot of networking opportunities. So these intensive summer schools that are often 2 or maybe 3 weeks long, you go, you live in a dormitory, you do computational neuroscience or similar for 9-10 hours a day, and you get to know people really well. I went to one of these summer schools, the Cosmos Summer School. I didn't go in 2018, I went back in 2013. And I have a lot of fond memories. I learned a lot. And I also made lifelong science friends. And I can tell you very, very specifically that my lifelong science friends that I made at Cosmo are those with whom I am building Neuromatch Academy today. And so that's how strong those connections are. And that's what we were trying to target with Neuromatch Academy as well. So these traditional summer schools in computational neuroscience and in other areas, they have a lot of good things going for them. There's a lot of value, a lot of benefit that you can get from going to these summer schools. However, they are also very expensive. So because you go, you live in a dormitory, you have to travel there, there's food involved, and then they have to bring in outside speakers that physically fly there and so on. They're quite expensive to run, and therefore they're quite expensive to participate in. So sometimes it can cost upwards of $4,000 just to go to one of these summer schools for 2 or 3 weeks. Because they involve travel, sometimes to slightly out of the way places for people who are coming from all over the world, they also have a high carbon footprint. And these two things together, also the fact that you have to actually physically go there and leave like your real life behind, makes them less accessible. And also less democratic as a result. A lot of people don't have the luxury of just kind of jetting off for 2 or 3 weeks at a time and leaving behind their real lives. Maybe you have another job or you have childcare responsibilities, and you can't just drop everything and go to one of these summer schools for 3 weeks. So this creates a divide between people who can go to these summer schools, who can afford to go to these summer schools, and those who can't. And that kind of perpetuates socioeconomic inequalities in computational neuroscience and related education. And last year, this was compounded by the fact that COVID-19 happened and none of these summer schools could happen anyway. So nobody could go. And so this actually created an opportunity, but also a real need for creating something that would fill this gap. So because summer schools are so critical to networking and to lifelong science friends and to other professional development opportunities that are very beneficial for people's careers, especially at this critical stage of their careers as like PhD students and young postdocs, we needed to fill that gap. And we needed to fill that gap in a way that that paid attention to all of these negatives that happen for these summer schools to try to bridge the divide and make it a lot more equitable. And so we created Neuromatch Academy as an online summer school. So it would have no travel, no geographical borders, and so on. And as a result, we could, due to grant support as well, significantly reduce or even waive the attendance fee. And so we were able to scale the attendance fee by the median national income. So this way, if you're in a country where the median national income is quite a bit higher, then you pay a little bit more. And that's kind of much more fair than just a flat fee for everyone. And then we also used some machine learning, which I'll describe in a second, to help build small group interaction, because when you have people spread out across the world, it's hard to facilitate those connections. And so we tried to build small groups of students who would have similar interests, similar goals within the school, and maybe even similar native languages if they chose to use that in their pod matching preferences, so that they could make those lifelong science friends and build those connections that are really critical. Okay, so our goal in building this program at Neuromatch Academy was really threefold. So I've told you about kind of the social aspects, but of course there's science as well. So we wanted to introduce students around the world to the idea of what is computational neuroscience, and also this year, what is deep learning? What can we get from these topics? And how do we also do them right? So how do we remove biases? How do we go beyond just kind of throwing toolkits and tools at these questions, and how do we gain real insight? And then we also wanted to teach people not only to understand computational neuroscience and deep learning, but to also learn to actually do it. So to select and use some of the state-of-the-art computational neuroscience and modeling approaches that would allow them to ask and hopefully answer really important and interesting questions. And then we did that algorithmic matchmaking that I told you about. So this facilitates our ability to deliver individualized attention from teaching assistants, if you're a student in what we call the interactive track. And you get individualized mentoring from faculty and industry professionals through the group projects that we match you with. And this allows you to meet like-minded peers and make lifelong friends, we hope. And so we hope through this program that what will happen is that we will facilitate students' ability to learn anywhere that there's an internet connection. So we're working on actually ways to get around that as well. But if we can provide access to this excellent and high quality interactive computational neuroscience education, we can actually build the next generation of scientists that have these skills and can use them to further science and medicine around the globe, regardless of where they're physically located or their ability to pay that $4,000 price tag that I mentioned. So I'll take a quick detour here and just briefly go over what is computational neuroscience, because I'm not sure that everybody here has a good sense of that. So brains, including yours, I hope they really like math, or I hope that yours actually likes math. But we can also do a lot of good by studying brains with mathematics. And so this is what computational neuroscience does, is it attempts to build theory and mathematical models that describe what the brain is doing from a computational perspective, both at the level of individual neurons all the way up, individual neurons and chemicals all the way up to networks of activity and information processing. So this is the Wikipedia page on computational neuroscience. It's funny that it's complete with this warning about maybe being too technical for most readers to understand. And I don't agree with everything on this page, actually. I think that it's not quite right to say that computational neuroscience is not directly concerned with biologically plausible models or biologically unrealistic models. I think that all of these things are pieces of computational neuroscience. So you can have engineering inspired topics like control theory. You can have quantitative psychology and behavior that's part of this. You can have machine learning and neural networks, AI. These are all things that I think are actually part of computational neuroscience. The way I define it is that basically, if you are studying brains and what they do with any sort of mathematics or engineering, you are doing what can be called computational neuroscience. So basically, what we'll do is we'll have some sort of measurement of the brain through neuroimaging or behavior even, so you can get a sense of how brains are working and what computations they are performing. through behavior alone. You can ask people to answer questions about what they see or hear or how they move. And that can be a window into how the brain works. And then we want to build, using modeling and deep learning, models that can help us answer questions about what, how, and why the brain is doing what it's doing. So what is the brain doing? How, what algorithms is the brain using for that? And also why is the brain doing what it's doing? What kind of goal is it trying to solve? And to answer these questions, we can build lots of different kinds of models. So we can build spiking neural networks. We can build generative probabilistic models. We can use machine learning, deep learning. We can build models that are either deterministic or stochastic, so noisy. We can build models that are linear or nonlinear. And this is certainly not all of the models that are out there, or even all of the model categories that are out there. I just wanted to give you an idea of kind of what this might look like. So the idea is you put all these things together, you take EEG, you have behavior, you have brain stimulation maybe, you have other kind of measurements of neural activity. You put all this stuff together and you write code. And that code will implement a model, either a machine learning model or other computational modeling that will try to help you understand what the brain is doing, how the brain is doing what it's doing, and why. What goal is the brain trying to solve? And so these are the types of models and ideas and categories of questions that we introduce in Neuromatch Academy so that you can start to build these models on your own. So computational neuroscience is really cross-disciplinary. I bet you there are a lot of you in this room who are coming from a lot of different fields. And scientists truly come from all sorts of fields to come together to study the brain. So we have psychologists, physicists, engineers, mathematicians, computer scientists, and so on. Basically, if you have any sort of math or programming skills, and you have any sort of interest in reverse engineering the brain or the mind, you can be a computational neuroscientist. And this means that you can study topics like learning, memory, perception, decision-making, cognition, information processing, movements. So how do we actually move around our environment, and how does sensory motor integration work? Medicine and neurology can also learn a lot from computational neuroscience. And so can AI and robotics. And so there's a lot of collaboration across these disciplines, across these fields of study. Computational neuroscience is really big and it's really exciting. I think that we're trying to reverse engineer one of the most complex and fascinating systems that we have, which is the brain and the mind. And I think it's pretty cool that we now have these tools and techniques that will allow us to get at that from a computational and quantitative perspective. So, have I sold you yet? Do you want to be a computational neuroscientist if you aren't already? So how would you do this? So of course, you need to go to school. You need probably at least a master's degree, if not a PhD, depending on what you want to do. But you also could get into doing research in computational neuroscience with a bachelor's degree to help out supporting that research, even if you don't have those advanced degrees. And this is where we're hoping that Neuromatch Academy can come in and kind of supplement that. In addition to the formal degree programs that are out there, Neuromatch Academy has 3 weeks of super, super intensive 10 hours a day, well, 8 hours a day plus projects, education. And it's really hands-on. And it's hands-on in a way that gives you all of the tools that you actually really need to do computational neuroscience. And I'm going to point out here that this list of topics is the kind of thing that you would cover in a computational neuroscience PhD degree. You would do this over like 5 years, and we're doing it in 3 weeks. So it's kind of like drinking from a fire hose, and we don't really expect everybody to retain every single tiny little detail as they go through the course. The point is that we introduce you to the topics and we give you tools and techniques that you can use to try stuff out on your own. And then the materials are there if you want to go back and you want to do a deeper dive into one of these topics. So in our computational neuroscience course, which we introduced last year, we have introductions to models, Then we do some machine learning and dimensionality reduction. We have a whole series on stochastic models, and we have a whole series on non-stochastic models. And then we also have an entire deep learning course that's new this year. So in the deep learning course, we learn all of the kind of most modern tools of deep learning. We talk about unsupervised versus supervised learning, generative adversarial networks, reinforcement learning, and so on. So each of these is kind of a PhD in a box. It's a PhD in 3 weeks. And so it is really at lightning speed. But the hope, again, is that you don't need to retain everything. Just sit there and be a sponge and soak up as much as you possibly can, and then go back to it later. And the way that we allow you, not allow you, but really encourage you to go back to it later, is that all of the materials are online for free, forever. And the materials look like this. So you have an introduction video for each day. And each day, this introduction is going to say, kind of, what is the topic of the day and how does it get used and what are the kinds of things that you'll be playing with? How is it used in real science outside the tutorials? And then we have each of these individual tutorials, which I'll go through in a second. Then you have an outro video that's supposed to kind of give you a broader perspective to say, okay, if you wanted to go further in this topic, where would you go? Last year, we had live Q&As on every single day. This year, we'll have these per module, not every single day because people were exhausted. And then you also get all the slides. So you can go back to these materials anytime you want and go back into the tutorials and actually run the code. And the tutorials look like this. So these are Google Colabs, where there's the outline here on the left. And then each of the tutorials has objectives, what you're supposed to actually learn. And then you can see there's a little hint right here. There's actually code in all of the tutorials. And sometimes there's little pieces of it missing. And so the tutorials have little mini videos that go with them that introduce the idea. And then it says, go play with it in the tutorial and play with it on your own. And then you can actually plot the output and see the results. And so the code is written in a way so that you should have to do only a little tiny bit, and all of the packages are coherent. So the variables have very similar names across all of the 3 weeks, so you don't get lost as much as possible. And we've really tried to set this up so that you can go through this in your pod with a TA in the interactive track, which I'll introduce in a second, or you can just go through it on your own, or you can go through the interactive track and then come back to it later. So the whole point is, again, to make this super accessible and super transparent so that it works for everybody as much as possible. So I mentioned that interactive track. At Neuromatch Academy, we have an interactive track, which is those TA pods. And you have the tutorials, and we have some online forums. This year, we'll also have a Discord server for our interactive community. You also have mentorship and professional development in small group projects. These kind of go together so that mentors are assigned to your small group project to help guide that project. We have some professional development sessions that are about open science and interpretation and transparency, and some industry and academic panels, some job fair kind of things. And all of this you're going through in a TA pod. So you have a TA and a few students that go through it with you. So you really get that tight connection. And if you're on the observer track, you get access to the tutorials and to the forums, which last year were through Neurostars, and we're going to be partnering with them again in a slightly different capacity. And you can do this either in the 3 weeks in parallel with the interactive track, or not. You can do it a day here, a day there, come home for Christmas or take a break or something like that, and maybe go through a few days. These are up forever for free. And so please feel free to use these materials however you wish, whenever you wish. If you're in the interactive track, though, your schedule is going to be pretty intense. So I know some of you who are here might have actually applied to the interactive track. And so I want to give you a taste of what you've got coming. So because we're a global summer school, we're a global organization, we have to run 24/7. This means that we have to pay attention to all of the different time zones and make sure that we can cluster you into those pods in a way that means you're awake at a normal time and you don't have to get up at 2 o'clock in the morning to do your tutorials. So the way that we've done this is we've split the entire world into 3 core time zones, which we call East Asia and Pacific, Europe, Africa, and the Middle East, and Americas. And so these are kind of just the 3 broad chunks of time around the world. And then within each of these time zone, these broad time zones, we set up the day so that the core of what you're doing with your group is all at the same time. So if you happen to be at the later end of a particular time zone, you'll have what we call project time first in the morning. You meet with your small group project team, so that's just 3 or 4 other people, and you work on your group projects. And then you meet with your larger pod, up to 10 students, or about 10 students per TA. You do your tutorials, you have a nice little lunch break, which for you might be slightly in the afternoon. Then you finish up your tutorials and then you're done. So that's what we call track A within zone 2. So this would be track 2A or zone 2A. We also have cases where maybe you are kind of shifted into the middle of that broad swath of time. So you do a little bit of project time, then you do your tutorials, and then you do a little more project time. Or maybe you're earlier in that time zone. And so as soon as you wake up in the morning, you need to get on those tutorials. So you meet with your pod, and then your project time is in the afternoon or evening for you. And what this does is it means that within a group of 4 or 5 hours, 6 hours, we can actually have people get together and work on the tutorials at the same time while also giving time for these projects. And we can do this in a way that means nobody has to get up in the middle of the night or wake up super early or stay up super late in order to meet with their groups. So the pods are constructed in a way that, that is cognizant of these time zone constraints, but also cognizant of other constraints. So you are part of a TA pod. Within each TA pod, there are likely to be 2 or so group projects that have 4 or 5 members each. And then there are also other pods like this. So we put several of these pods together within the same time zone grouping, a large time zone. And we call this a super pod. And this gives you a chance to, yes, you get to know your group members very well, and you get to know your pod pretty well, but you also get a chance to interact directly with students in other pods within your super pod. And this kind of expands your community a little bit, while also allowing you to meet people from all sorts of other places geographically, even within the same kind of general time zone. So this is how Neuromatch Academy is built. We have pods and group projects, but we also have super pods. And the whole way that we do this is through an algorithm that actually optimizes, based on all of these constraints, your pod placement. So we match you by time zone constraint, by your preferred language. So I'll mention now and go into a little bit more detail later that we actually have instructional support in multiple languages. All of the main instruction is in English, but we do have instructional support in other languages, and I'll discuss how that works in a second. So you can indicate if you want to be in a pod that has instructional support in a language other than English. We also use algorithmic matchmaking to match the mentors to the group project. So each group project might be on a completely different topic with a completely different data set. And so we can actually match faculty mentors who are volunteers who want to come in and kind of just help out for the group projects. So we can match those faculty mentors and their expertise to the group projects, also within the constraints of the time zones and the geography and so on. And so this is where we get this faculty and industry professionals as well, where we can do one-on-one matching that allows you to kind of network in a broader community where we say, hey, you two would probably get along scientifically, maybe you should talk. So this is the big picture that we're trying to build. Ultimately, what we hope students are going to get out of Neuromatch Academy is not just a lot of really useful knowledge and skills, because that's really important. And we know that computational neuroscience education can really benefit from this kind of program. But we also hope that students will get a worldwide computational neuroscience community. So we want to help our students grow outside their typical and local communities at their local school or university, or even within their town or their state or their country. We want to build a community that's truly global, that helps scientists connect with people around the world that will be their lifelong science friends. So we can all be part of this massive global community. And it's really important that we do this because this is the type of global community that's going to celebrate and support diversity, inclusion, and cooperation across computational neuroscience and across science in general. If we knock down these geopolitical borders this way, I think we're going to build a better scientific community for everybody. So this is the vision. This is what Neuromatch Academy is trying to do. And we started this about a year ago. So it was late April 2020, COVID had just started. I was talking with Paul Schrader, Gunnar Blom, and Conrad Cording, and they had just invited me to be part of driving the Cosmos Summer School, which I mentioned earlier, which I had been a student at 8 years ago. And they had invited me to join the organizers committee. And we were planning it, and then COVID hit and we couldn't do it anymore. And we thought, well, let's just put it online and let's see if we can get some other people to help us, because all these other summer schools are also going to have to be canceled because COVID. We can't hold in-person summer schools right now. So we collected Shauna Scola and Brad Weibel, who had been, Brad had been involved in the Neuromatch conference side. And then we started collecting other people who had been running all those other summer schools. And pretty soon we had 300 plus organizers who were all coming together to build this one massive computational neuroscience school that would be run online, and it would have videos and tutorials and be coherent and reach everybody across the globe. And it was just astonishing to see the level of dedication and love and support that all of these faculty and students and postdocs from around the world, they all came together to build this thing. And so this is kind of where we were last year. This was our student population and TA population last year. So we had over 1,700 interactive students signed up to do this. And we went from, we conceived of this in April, and by July it had launched. So the fact that we were able to bring on 1,700 interactive students and collect over 5,000 observer students who signed up to say they wanted to use the online materials for free, again, like just use them, great. This was really just truly humbling to see that people really wanted to do this and people really wanted to be involved and help build it. And these nearly 2,000 interactive students and over 6,000 observers. These interactive students, especially though, we had almost 200 teaching assistants, about 190 teaching assistants who joined us to lead these small groups of about 10 students, 8 to 10 students each, to go through all the tutorials. And you can see that our geographic distribution was pretty good, although we're missing quite a bit here in Africa. And we're trying to do better, and we're missing a bit here and a bit in South Asia as well. And so we're trying to do much better this year. And I think a lot more of the map is blue this year. So we have a lot more participation from the map this year, which is just really truly wonderful and again, humbling to see. And so this was our breakdown of language support. So I mentioned that we provide instructional support in languages other than English. And the way that we do this is all of the tutorials are in English, but they are captioned. They have closed captions that are not just automatic, but they actually were built by humans as well, in English, but also in Spanish and in Mandarin. And then we were able to match interactive students and TAs based on their native language if they chose to have that. So this way we could say, if you would like to be in a pod where your TA speaks your native language, so you can ask questions and discuss with your pod mates in your native language instead of having to do it in English, then you can do that. And so this was the breakdown of the number of pods we had in a number of different languages. I think we had up to 14 languages, including English. And so this was also very cool because this gives you the chance to interact with people maybe from your local or broadly global community, but you don't have to do it in a second language, which I think is really important for comprehension and understanding. So this was our geographic and demographic breakdown last year. And then, of course, you want to ask, well, did it work? Did people like it? And so last year we had over 345,000 views on YouTube. So we stream all the content to YouTube as well. And we had over 36,000 watch hours, and everything is licensed CC BY on GitHub. And for those of you who are not copyright lawyers, what this means is that you can use this for free forever as long as you attribute it. That's it. So go ahead and just use these materials. You can repurpose them for whatever you're doing. If you want to create your own pod and go through Neuromatch Academy with a couple of your friends, you can do that. You can do whatever you want with these materials, basically. And then we also wanted to make sure that people were engaged and that they stuck around and that they continued to attend the course. So we had only 15% dropout, and those were generally for people who had other family or other responsibilities that ended up interfering with their ability to fully participate. And I want to highlight that this is really in contrast to a lot of courses that are kind of the standard massive online courses like MOOCs. So if you look at Coursera or Khan Academy, those kinds of things, a lot of times they have a much higher dropout. It can be up to 85% dropout instead of 85% retention. So we like to think that people actually enjoyed the course, and hopefully, people are signing up again, so that's a good sign. And then we also did specific evaluation of all of the components. And so those components that were rated slightly lower, so there was the question and answer session had the slightly lower rating. So we're actually completely revamping that this year. And trying to improve the materials that were rated a little bit lower. So this is an ongoing iterative process. But what this shows us is that just like those in-person summer schools, there's something that works about these online summer schools. They promote equity, diversity, and inclusion, but they also provide high quality education. And it means that they're really filling this niche, that they're not going to replace those in-person summer schools. You know, there are things you can't get online. You can't have late night coffee sessions or go out and grab a bite to eat with your friends if you're doing summer school in Zoom. But you can get a lot of other great interaction and make lifelong friends. And so we are very hopeful that this online summer school approach, because we're doing it not just for computational neuroscience again this year, but we're also doing it for deep learning. And we're really hoping that this approach is going to expand the network of scientists who are doing this around the world and make this type of content and this type of experience accessible to a great many more people than would otherwise have access. So if you did apply as a TA or a student to either the computational neuroscience course or the deep learning course this year, we're rolling out the student acceptances. We started doing that last week. They all are out the door, I believe, at this point, with a few exceptions. If you applied and you have not heard, please, please, please check your promotions or spam folder. We use a bulk email system, so we can email thousands of people at once, and sometimes it ends up in spam. So please check your spam folder. And if you did apply and it's not in your spam folder, send us an email or send us a direct message on Twitter or something so that we can check on it. And also, if you missed the application deadline this year, don't worry, there are lots of other ways that you can still be involved. So you could definitely be an observer. You can go through the observer track and join the community that way. But I also want to point out that the Academy is not the only thing that Neuromatch does. So Neuromatch also has an online, free or very cheap computational neuroscience conferences. And so we're going to be running 2 of these this year, one in the fall, which will be smaller and really targeted to computational neuroscience. And then the plan is to run another one in the spring that is broader and brings together neuroscientists from lots of different communities. And the last thing that I'll say here before finishing up is that we are really trying, and our ultimate goal is to make this truly worldwide, so that we don't exclude anybody. And this includes not excluding anybody, even when there are geopolitical borders involved. So one of the things that you are, maybe potentially aware of is that we are a United States company, but this means that technically there are sanctions that prohibit us from providing goods and services to certain other countries around the world. One of the main ones that you might be thinking of is Iran, that there is a wall between Iran and the United States, and Iran and a lot of the rest of the world. And so this actually, based on United States law, would have prohibited us from providing goods and services to Iran, including getting students and TAs from Iran. So we applied to the United States Office of Foreign Assets Control, and we got a license that allows us to provide these educational services, including TA stipends, to people who are in Iran, with a lot of, logistic challenges, of course, but we're legally allowed to do it now. And we've applied for an expanded license to reach other sanctioned countries as well. And I think that this is really important because geopolitical borders should not be borders to science. Science and medicine and scientific inquiry needs to be without borders, without geopolitics involved. And so this is something that we're really committed to doing and really trying very hard to accomplish. So if you did apply to the Academy, I want to leave you with our kind of de facto slogan that got created last year, which was, as Conrad and Paul and Gunnar and I were starting to launch this and bringing in Sean and Brad and all of these other people, Conrad kept saying, come on, let's do this together. Like, I'll get this other person involved. It won't be much work. How much work could it be to just put up videos and tutorials online? And of course, we all know, anybody who has heard anything about Neuromatch knows that this is totally a lie. It is a lot of work, but it is absolutely totally worth it. And I'm just so grateful to be involved in this effort and to be able to work with all of these wonderful, dedicated, brilliant people to build this school and this program and the conferences with Neuromatch conference as well. So that's it. I'm going to stop there. I'll thank, these are all of our funding sources and supporters from last year. And we have a number of them kind of coming back this year to provide us with a little bit of funding to support the TAs. Almost all of the money that we get from sponsors goes to TA payments because we pay them a stipend, a living wage. And this is a compilation of all of the, or a lot of the pods that we had last year. And so you can just see all those happy smiling faces and people who actually made friends online, which is really fantastic. So I'll stop there and I'll just say thanks very much for coming. And we've got some time for questions, which is great.
Thank you, Dr. Peters. Anybody with questions? I'm going to ask you one question that was put in the chat, and that is, they applaud you for the Neuromatch Academy initiative. It is very well thought out and interesting aspect in matching mentors and students. And what they ask, what kind of algorithm did you use and if it's unbiased?
Yeah, this is a great question. So the primary algorithm, you can actually go and download. It's on GitHub, so you can just go get it. It's on either the Neuromatch repo or TittyPat's repo. And the bias. So I assume that what you mean by unbiased is that we aren't like training it and testing it necessarily on different data sets. Really, this is just a constraint satisfaction algorithm. So we say, I want to build pods that must be in the same time zone and that ideally are matched in terms of seniority, at least a little bit. So this way we don't have a pod that is made up of all postdoctoral researchers and one undergraduate. That would be very uncomfortable maybe for the undergraduate, or vice versa, all undergraduates and one postdoctoral researcher. We try to kind of have junior and senior pods, so that's another constraint. We have constraints on data set preferences. We have constraints on gender identity. So we do not build, this is self-reported, so we don't build pods that are, all men and one woman, or vice versa, or all men in general, or all women in general. We try to have those mixed. And I don't remember what all the other constraints are at this point, but really, like, we basically say, here are all the constraints, and then there's an optimization algorithm that figures out where to put everybody to satisfy those constraints. And the original matching algorithm is up on GitHub, so you can actually just go download it and play with it. But I'm hopeful that what we'll do this year is, as we continue to refine this algorithm, the idea is that this will be packaged into an API, and that other people can use it and play with it and extend it, can fork the repo, can play around with it, and make sure that that it's doing exactly what we need it to. And if you have suggestions for other constraints that we should try to satisfy, or other things that we should keep in mind when doing the pod matching, please reach out and let us know what you're thinking, because we can't satisfy everything, because then the optimization becomes impossible to solve. But we can try our very best, and we place priority on different types of constraints. So let us know what you're thinking.
Thank you. Thank you very much. That's very useful. So there's a comment here, and it says, one aspect which needs to be considered in promoting equity and global inclusive in internet cost is internet cost. Being online for 9 hours over many days can be very costly in some parts of the world. Can any assistance be provided in this respect, perhaps partnering on the ground with telecom service providers?
This is also a fantastic question, and it's something that we've been thinking about a lot of how to do. So we've been talking about partnering with universities who might be able to provide internet access, or other local organizations that can provide internet access. And we know that there were a couple places without stable and affordable internet access last year, where there was a local community that decided to say, like, hey, we're going to provide you a space, and we're going to provide you with internet access. And they just did that on their own, and that was fantastic. So we're thinking about how to get around this barrier, because you're absolutely right. Internet is not a basic, right everywhere, unfortunately. So one of the other things that we've discussed is maybe partnering with universities, where we can send the material ahead of time and have them download it ahead of time, so that it's available offline without having to stream the content. And that, so Zoom has call-in services, so you can at least participate with audio without having to have streaming internet. This doesn't get away from the screen share aspects for the peer programming, but there are other things that we're thinking about. And the partnership with local telecoms is a great idea that I don't think we've explicitly explored yet. So thanks very much for that idea. And I'll take that back to the technical team and see, it might not be possible this year. We're barreling towards the beginning. It's only in a few weeks, but we want to continue to improve. And so that's a great idea to go forward. Thank you.
Thank you. One question: what level of programming skills would be required to take part in this program? And is it possible for participants of the observer track to network with other students and maybe engage in research projects related to computational neuroscience?
This is a great question too. So I'll answer the observer track question first. Last year, we encouraged observers to sign up for NeuroStars, which was our online forum. And this year we are exploring how best to help observers connect. And we're trying to think about messaging services and other ways that we can actually promote them networking. We do provide matching for observers, which says here, this is a mentor who has expressed interest that kind of matches what you said. And so, like, you guys should get together and talk. But observer to observer matching, I don't think we're doing right now, but that's also an excellent idea. So we're exploring how best to do this. And if you've got ideas, like, please come join us. We need the help. And then, sorry, what was the first part of the question?
The first one was how much programming skills would you be required to have?
Right, programming. So you definitely need to have, I wouldn't say you need to be an expert by any means, But if you've never written an if statement or a for loop before, and you don't understand really, you don't feel comfortable like declaring variables and writing math equations in code, this would be very difficult for you. So for those of you who have some programming experience, but maybe it's a little rusty, it was a few years ago, we do have refresher courses that will help get you back up to speed. But if you are just starting programming for the first time, you probably should wait a year, or you can have a look at the materials and check it out and see. I would not suggest you come in with no programming and like no linear algebra and those kinds of things. You're not going to have a good time. You're just going to feel lost, unfortunately. And that's just the nature of the beast. You can't do computational neuroscience without the programming and the math. But we've got a lot of pre-course materials that we're developing and a lot of prerequisites. So those are all available on our website and on the GitHub repository. So go and check those out, and this will help you understand whether your level of programming right now is sufficient or whether you should maybe wait a year and do some of the Python courses that we recommend, where you can go through either at your local university or on Coursera or somewhere else and get those prerequisites so that you get the most out of the experience.
Great. How can I become an observer?
That's a great question. We have not launched the observer sign up yet, but what will happen is that we will put a banner up on our webpage. We will send it out via Twitter, LinkedIn, Facebook, and our other social media. So make sure to follow us on whatever social media platform is your favorite. And it'll just be a sign up form. And basically you can go be an observer right now if you want. You can go to the website and use the materials now. There's no restriction on that. Like absolutely just go. That's fine. But if you want to be involved in the matching and other networking and that kind of thing, then you'll need to just sign up, and it'll be just a form. And that's it. And you just sign up and then you're on the list.
So another question is it necessary to be present for live tutorials? What if my time doesn't match, so I may miss the online lectures? But you will be matched to lectures that are at your time zone at DIA, so you don't have to worry about that. That's the beauty of this.
Yeah, that's exactly right. Is that the one constraint that we do not relax is the time zone matching, because it's really important for you to be there. So if you cannot come to the live tutorials for the entire 3 weeks, you can't, you have another job or you have other responsibilities or those kinds of things, then the observer track is the right way to go. The live tutorials are really important to attend with your pod, because otherwise, how are you going to get that rapport, that kind of lifelong friends, the support from your teaching assistant to say, well, I got this far in the tutorial and then I got stuck and I need help. And your teaching assistant is there to help you. So it's really important that you attend the live lectures. And we are telling students that if they can't attend, if you have to miss like one day, maybe, but think about that. This is 3 weeks, 8 hours a day. If you miss one day, you're missing 1/15 of the course. That's like you're missing an entire 2 weeks of class in a typical kind of semester, or an entire week of class in a typical semester approach. And so it's really hard to catch up if you miss those live tutorials. But as Martha said, you're matched on your time zone, and that is like the biggest constraint. And so you'll be put in a time zone where it's normal for you to be awake based on your preferences, not based on your geography. You tell us which time zone you want, and that's what we use. So if you like to be up in the middle of the night, cool, you can do it in the middle of the night. That's fine.
Thanks, Megan. Megan, we have time for one last question, and that's actually going to come from me. And that is that, so most of the materials and most of the applications are going to be on your website.
All of the materials, everything is on the website.
And everything on your website. Fantastic. And if anybody wants to contact you with extra questions, could they do so? Could you give us your email?
Yeah, sure. So I'm going to put my 2 emails actually in the chat. So this is my UCI email if you want to ask me about UCI related things. And if you want to
UCI stands for University of California, Irvine, for those
That's
of you
right.
that do not know.
Yeah, thank you. And if you want to email me about Neuromatch stuff, you should email me here because that helps me separate my life.
Right.
But then if you have social media, especially Twitter, we're very active on Twitter, and that's where we send out a lot of our announcements. So if you want to follow us on Twitter, that is the Neuromatch handle, and this is mine. And so these are all ways that you can get a hold of us. We also have LinkedIn, so you can follow us on LinkedIn. We've got a Facebook page. I think someone just made an Instagram. So there's lots of different ways that you can engage with us on social media, but the fastest one and the most direct route is either email, or actually the Twitter handle and the Twitter direct message system. We've got like a team of people monitoring that. So that's a good way to get a hold of us. And to follow updates as well.
That's great. Megan, thank you so very much for this very, very informative session. I hope that everybody enjoyed it as much as I did. Please, if you have any more questions, I will stay around for a couple more minutes so that you can put them in the chat. We're going to try to put all the questions in World Women in Neuroscience. So on behalf of World Women in Neuroscience, I thank you for being here. And thank you, Megan, so much. Have a
Thank
very
you for having me.
wonderful afternoon, everybody. Bye-bye.
Thanks a lot. Bye.